Whether you're studying chemistry or not, the terms acid and base are something that you are probably familiar with, but what are they actually? In chemistry, this may seem like it has a simple answer, but it doesn't really have a simple answer. You see, acids and bases were originally just kind of categories of substances that did similar things. And so what we found is that over the course of human history, there were certain types of compounds and materials that acted in specific ways. We found that if you hang pieces of metal inside buckets of what we deemed an acid, that they would start to change color, and we used those to scrape off that color and turn into paint. That was a practice that the ancient Greeks actually did in order to make white one of the colors that they were able to use. Now, you may like start making fun of them because they were using lead paint, but I mean, that's something that we were doing here in Canada until it was banned in 1976. So it's a pretty ancient technique, but it was a property of the materials that they were able to use. So when we define an acid and a base, really they're defined first of all by their characteristics. You see, they're kind of opposites. Acids tend to taste sour, and if you think about eating like a lemon or some kind of citrus, they're very high in acid, which is what gives them that sour taste. Bases, on the other hand, tend to be quite bitter. Think of eating like a very dark green vegetable like broccoli rabe. It tends to be a little bit higher in bases, which makes it have that bitter taste. An acid will react with metal, and when it reacts with metal, they tend to produce hydrogen gas, whereas bases tend not to react with metals. Both of them do form what we call electrolytic solutions, meaning that they both conduct electricity, they both change the colors of dyes, and they'll often turn the same dye different colors. And a great example is litmus, which turns red in an acid and blue in a base. Acids tend to feel a little bit sticky to the touch, whereas bases tend to feel slippery to the touch. And the other characteristic that they have is that they neutralize each other. So these are just the general characteristics of acids and bases, but chemically, what makes something an acid or a base? Well, that really depends how you define it. And in this video, what I wanted to do is bring you to the first definition of what an acid or base is, which is what we call the Arrhenius definition. An Arrhenius acid is one that produces H plus in a solution. So that is really kind of the defining characteristic when it comes to this definition. So an Arrhenius acid will produce hydrogen ions, H plus, in a solution. So how do they do this? Well, really the idea is if you take some acid, and typically you'll see acids, the general formula written as HX, where X represents some negative ion. That acid will break down in water to produce those hydrogen ions and whatever the negative part of that substance is. This is what, by definition, makes it an acid, according to the Arrhenius definition. That H plus being dissolved in the solution is how we get an acid. So let's do a real example. Let's talk about, let's say, HNO3, nitric acid. If you were to put nitric acid in water, then that H is going to separate, and then you will also get the negative part, the NO3, and that will separate. So this is, by definition, what makes something an acid, according to Arrhenius. The other option is what is called the Arrhenius base. And an Arrhenius base is going to produce OH minus in a solution. So again, let's think about another example. What we would often see here is somebody would write MOH, where M just represents some positive cation that's going to be attached. And so when we dissolve these, the one thing you may notice is I put solid here, whereas I put aqueous up here. That's because when we have a base, they are ionic solids, whereas acids are actually covalent compounds. But then it's going to dissolve, and we are going to produce that OH minus into the solution. And this is what defines it as a base according to the Arrhenius definition. So let's look at a real example. So let's say we had sodium hydroxide. If it were to dissolve in a solution, we would get sodium ions, and then we would also get hydroxide ions. And it's those hydroxide ions that are causing all those properties that we ended up seeing before. Same thing, the H plus in the acids is what caused the properties of those acids that we looked at in the previous chart. This is just one way to look at acids and bases, is through the Arrhenius definition, and it's really the simplest definition, but it is by no means comprehensive, which is why we have further definitions of what it means to be an acid or base. And that's what I'm going to cover in my next video, when we take a look at other ways to define acids and bases. So thanks for watching, and I'll see you next time.